As we begin our discussion about conics, we need to get an idea of where these conics have come from before we dive into a study of each one of them. When we refer to conics, we're actually referring to what they call non-degenerative conic sections. So let's talk about this picture that we keep seeing. If I had a line, so here's my line, and I held that line kind of at an angle, and I tried to draw a circle with the bottom of it. So I'm trying to draw a circle down here. What's actually happening from this point is I'm making a cone shape with the outline of my line. But as I make that circle shape at the bottom, notice the top of my line is also making a cone. So I actually have a cone sitting on top and a cone sitting on the bottom. So I have a couple of cones here where I can use to kind of show you what this would look like. So here's the bottom cone, when I take that line and kind of make that, and there's a point where these two cones meet, and there's actually another cone on the top. Okay, I don't have a double cone, but it's called a double cone. It's got one on top, one on the bottom. I'm just going to use this bottom one for now to talk about these. When we talk about the non-degenerate conic sections, we're not talking about this point where they cross. And we're not talking about the line that I used to create it. What we're actually talking about is we're taking a plane and we're going to cut into this cone different ways. So the first way I want to cut into this cone is at an angle. And when I cut in that angle, what I actually do is I slice off a piece of the cone, and I only catch the bottom cone, so I get this parabola shape. Okay? We've talked about parabolas, and there's that shape. Now, if I take my plane and I cut straight on, I come into this thing and I hit it straight on and I cut, I get this circle shape. Now, if I'm not perfectly straight when I cut that, and I'm kind of tilted as I come into my cone, my circle gets flattened out into this oval shape. That's called an ellipse. And the last one, which is hard to do because I don't have two pieces, but if I could cut this bottom cone and the cone that's on top, what I actually get is a parabola at the bottom and a parabola at the top, so I kind of get two of these parabolas. When we have two of them, we call it a hyperbola. So those are the four conic sections that we're going to explore in this unit on conics. Now, some of the things we like to talk about with these conic sections. We like to talk about their lines of symmetry, obviously their domain and their range, and then their intercepts where they cross the x and y axis. So I put a couple up here. Let's look at one of these. We'll start with my parabola here. So here's my parabola. So that cone is being cut kind of at an angle and only hitting one half of the cone. But as I look at my parabola here, I can certainly pick out my y-intercepts and my x-intercepts. If I want to talk about lines of symmetry, here's that line that cuts it in half. It only has one line of symmetry. It happens to be the y-axis. And then when I talk about domain and range, we've done this with parabolas before, but my domain, I'm talking about my x's. Notice that it goes this direction and the negative direction. So for my domain, it ends up being all real numbers. My range, however, is a little different. My range stops right here. I get y values that go up, but I stop right here, right at this point, right at this vertex point. So my range would be all the y's greater than or equal to -2 in this case. Now the interesting thing about parabolas is we usually talk about vertical parabolas, but we can also talk about horizontal parabolas. And then these two things kind of switch. Our domain becomes a little more limited and our range becomes all real numbers. But we'll get into that when we study parabolas a little more in depth. For my circle down here, we have studied circles before as well. Things are a little more straightforward when it comes to intercepts. The x and the y intercepts, it actually has 4 of them in this case. And as far as lines of symmetry, it certainly has this one, x equals 0. It also has y equals 0, but it has a whole lot more than that because I have all these lines that I can draw. It actually has an unlimited number of lines of symmetry because I can cut that circle in half lots of ways. For my domain, we're talking x's. So my x's stay below 5, but they stay above -5. I never get anything outside of -5 to 5. And I have double values, which is okay, but I stay between -5 and 5. And for this particular circle, my range does the exact same thing. My y's go from -5 to +5. I don't go outside those two boundaries. Now let's look at this ellipse. Notice with the ellipse, it's just a little different than the circles because now I only have those two symmetry lines. I can't draw in those unlimited ones. I've got x equals 0, y equals 0. The intercepts are also easy to pick out. It's where it crosses the x and where it crosses the y-axis. And now I need to talk about domain and range. Here's where it's a lot different than the circle. My domain is limited by -3 and +3. This particular example stops between 3 and -3, but my range is different. They're not the same numbers as the domain. Last one we've got here is a hyperbola. Now, I've got a hyperbola that's going left and right, but imagine if this hyperbola would go up and down. The things that I'm going to talk about are going to be just a little different. It also has two lines of symmetry, two lines that cut it in half. In this case, it happens to be the x and y intercept. And with all of these, those can move if we move our conic section. But the the parabola had 1, circle had an infinite, ellipse had 2, hyperbola has 2. That's not going to change even if we move it around. The hyperbola only has x-intercepts in this case. Now, if it was a hyperbola going up and down, it would only have y-intercepts. And then we need to talk about the domain and the range. For the domain in this case, we're talking about x's. It starts here at 6 and goes to the right, but it also starts at -6 and goes left. So there's two parts to this domain. We're looking at all the x's greater than or equal to 6, but also all the x's less than or equal to -6 in this case. So we've got two parts to it. It's everything except what's between -6 and +6. These numbers in here are not included. My range for this particular example is everything, because it goes in the positive y and negative y direction, no matter which one we look at. Now, the unique thing we'll get to with the hyperbolas is what if this is turned? All of a sudden, what we do for the domain is what becomes the range, and what we do for the range becomes the domain. So that's an interesting characteristic when we get to those hyperbolas.